Hello, my dear students and the real SSC JE aspirants. Welcome for today's session, which is live in YouTube and in our ACE online channel. The main agenda of this program is to inspire you, talk about this great exam on SSC JE Electrical. Yes, this we will have in two parts. Today I will talk about the strategy, preparation, material, weightage, okay, the way to attack this exam, plus some basics, technical if possible. Pure concepts and important questions and the way to study will also continue on Sunday, that is day after tomorrow on 12th, again evening 7 to 8 p.m. See, in 2 hours I cannot do any magic, but as a teacher I would like to inspire you. Okay, so this exam is completely different, and ACE Online and ACE Engineering Academy, you know, we have a lot of competitive exams that we train for, and this is SSC JE we are talking. Yes, today we will be mostly highlighting on preparation strategy, especially electrical, and important question analysis will be on Sunday. Yes, we are talking about circuits or networks we call, and myself, B.S. Krishna Varma, one of the faculty in ACE since 2009. As today's session is mainly about the preparation strategy and how to approach, because before we talk about the paper, the subject, the bits, mentally preparing to attack and what caution you have to take, because these are competitive exams. It is not like your diploma exams or BTech exams. So that strategy will work and important. So today's session will be on that is session 1. Yes, before I start the session, I want to highlight this. Yes, everybody make a note. We are going to conduct a mock test on 26th May, 1 p.m. to 3 p.m. online mode for all the 3 branches, especially SSC JE. And this will be a national level test, and it will be more accurate. Okay, the questions we design will be almost matching to that level. Okay, so that will be main to give you confidence, okay, and prepare. So take this date, note down this date, it is on 26th May. So start your preparation, accelerate it and be ready. Afternoon 1 p.m. to 3 p.m. online mode. Okay. Yes, now the agenda for today's live session is this. Yes, it is preparation strategy for success in SSC JE. And the agenda is about introduction to SSC JE, brief introduction. I don't want to talk much because already you applied. About my subject, syllabus and chapter division, results and marks analysis, the weightage we'll talk. About ACE Engineering Academy and online, brief. Then recommended books and material. This is very important. Preparation strategy is what I will be highlighting more. And model questions, of course. These model questions will continue in second session, which is day after tomorrow on 12th also. Okay. Yes. Now about SSC JE. Yes, again everybody, let us quickly go through. Okay. Now you got this notification on March 28th by Government of India, Staff Selection Commission. And yes, these are very important dates, you know already. Okay. Application, tentative date of exams, hall ticket, etc., etc. Okay, you know this. Then Staff Selection Commission will hold an open competitive exam for recruitment of post of JE. Yeah, JE I call junior engineer, and I am talking about electrical. And the pay scale you see, it is between 35,400 to 1,12,400, and it may revise further, sir. You know, as you join over the years, it improves. 8th pay commission, 9th pay commission, it may come. So this is as of now. And vacancies, please go through the detailed link which I mentioned here. I briefly want to talk. You know, I am talking about E and M, electrical and mechanical and electrical. So wherever E and M, that is what I will be focusing as electrical. But of course C is for civil, M is for mechanical. So you see wherever E comes, okay, it is for electrical. Electrical, see here 121 post, and it is Central Public Works, okay. And here also total 37 post. And here also you see JE Electrical Center Water Power Research Station And here also Naval Ministry of Defense, excellent job sir, it is Naval. And there is a project, Farakka Barrage project, there also they want to recruit, okay. And here also E&M, Military Engineering Services, MES. Now here specifically post is not mentioned, but it is dynamic depending upon how many people retire, etc. Okay, this is brief introduction. And details of the post, you know, border roads, what is required, diploma and degree, okay, up to age. So this all you know, I don't want to go much deeper. And these are all the post. Military Engineering Services, you see now, electrical and mechanical, okay, very, very important sir. I had seen most of my, relatives, some of my relatives' parents did retire, okay, in military engineering. It is a very good government job. And then age limit and relaxation, you also know. Yes, if you talk about age limit, candidates must have born not earlier than 94 and not later than 2006. So all these are given here, okay. And for post which are up to 32, and this is the limit they give. And relaxation, yes, based on the categories, reservation, you have these relaxations also. Okay, this all there in detail in the link I provided, and you please go through very carefully. Then scheme of examination, briefly, you know, yes, we are talking paper 1, CBE or CBT we call computer based test, and paper 2 is descriptive. Details of these papers, yes, this is very important, I want to highlight. Yes, I want to highlight this. Now in that regard, yes, if you observe, when it is, when it is paper 1, yes, you see computer based examination. So in this regard, subject, general intelligence and reasoning, yes, 50 marks, 2 hours, general awareness, part A, and this is where we will talk technical, okay, about electrical, 100 out of 100, that is very important. So bulk of the marks come from this core part, that is our subject part, but you need to clear all, and you should be having basics of all these papers. Then paper 2 CBT again, here also, yes, if you observe carefully, yes, general engineering, 100 out of 300, that is very, very important, okay. Then the candidates will be required to attempt general engineering part, okay, and especially part B is what electrical, part A parts, you know, they are not our branches. And appearing for post of JE electrical are required to attempt part B of paper 1. And paper 2, failing which there will be rejected. So that is very interesting. And yes, objective, multiple choice questions. There will be native marking also, okay, this all you know, okay, I just want to brief out. And this is what I want to highlight. Mode of selection, the minimum qualifying marks of paper 1 and paper 2 as for open category unreserved 30% and all other categories 20 and OBC, okay, and economic weaker sections is 25. Now, though he mentioned qualification marks, but do you think such competitive exams are about just qualifying? I don't think so, sir. It is about beating the competition. Just getting 30%, 20%, you may get some rank which is very high. That does not mean you will get posting, right? So competitive exams means beat the competition. Just achieving this 30%, 25% or 20% is not the meaning here. You have to beat 95% of the candidates, 99% of the candidates. So please understand, sir. You know number of posting, for example. And if 1 lakh students write and 200 posts only there, so please understand you have to be in top 200 out of 1 lakh. So this is not to be misguided here. Though he said these are qualifying for next level, but that does not mean you will be ensured to be given posting. You have to beat the competition, please. Then, yes, procedure about applying, you know, okay. Go to this website. This is what I want to highlight. Go to this website. And now, yes, so after understanding what is this exam, what is the pay scale, okay, what are the postings and how professional and great these technical jobs are, let us talk about syllabus. Now, this session will be mostly talking about the subject. Now, the standard of questions in engineering subjects will be approximately the level of diploma. This is a very important, the level of diploma in engineering, okay. So, though BTech students can apply, but the exact level will be diploma level, okay. That is what please understand, it is diploma in electrical, and the details are like this. Paper 1, general intelligence and reasoning, general awareness and general engineering, I am talking about this, electrical engineering, okay. Then part B electrical, yes, this is the syllabus he gave, and this highlighted part is my subject we are talking, electrical circuits or networks, and altogether measurements, machines, power systems, basic electronics, everything is included. But this white color part is, I am talking about my subject, that is electrical circuits or networks. It is a fundamental rank 1 subject. So to learn big subjects, yes, this is the basic subject to start with. Now in that, yes, part B, electrical. In electrical, all this is the detailed syllabus. Of course, part A, civil, part C, mechanical, but part B, in that again, these 4 points is what I am highlighting, which belongs to my subject. And remaining points comes to machines, measurements, power system, etc., etc. But these 4 parts, basic concepts, circuital law, magnetic circuits, and AC fundamentals. Now we will go detail. Now detailed syllabus, again he elaborated, yes, basic concepts include concepts of resistance, inductance, capacitance. So we know the 3 fundamental passive properties with which electrical engineering can be modeled and understood is RLC. So yes, basic concepts introduces understanding these 3 fundamental components, RLC. Then concepts on current, voltage, power, energy, and units. Kirchhoff's laws and simple circuit solution using network theorem. So this is very major. Overall, if you see the previous papers which guide us, yes, Kirchhoff's laws and simple circuit solution with theorems is a big area to encash. Then magnetic circuits, though he mentioned, but I find that little problems came on magnetic circuits, but still important. Concept of flux, MMF, reluctance, different kinds of magnetic materials. Yes, material calculation for conductors of different configurations, straight, circular, solenoid, electromagnetic induction, self and mutual. So here this somewhat links with machines and measurements also. But yes, magnetic circuit itself, I had seen very simple problems on dot convention, calculation of MMF, flux, but it links with machines and measurements, so please focus on this. Then AC fundamentals, this is another big area, okay. Instantaneous, RMS, peak value, average values, representation of sinusoidal, simple series, RLC, resonance, tank circuit, polyphase system, of course in 3-phase. In polyphase it is 3-phase, star delta transformation, and DC and AC response to RL circuit. Now here even transient he mentioned, see, though here he highlighted AC fundamentals, but this comes under transient, okay, that we should be careful with. Now, so though he gave detailed syllabus here, everything very clearly. Now I categorize into these 10 chapters. So further detailed classification I did. So those who took subscription of our course in ACE online app, everything in detail, so detailed and accurate we made it, okay. And we further divided it into 10 chapters. So if you go with that, yes everybody. Chapter 1, that is what? Fundamentals, notation, symbols, units, formulas. So I elaborated more. Examples with RLC. Chapter 2 is DC circuit analysis, where register is a fundamental element. Here I will introduce reduction techniques, okay, mesh and nodal. Chapter 3 is about inductors, capacitors, basics of time variance. So chapter 2 is dedicated to register, but chapter 3 I will dedicate to inductors, capacitors, where time variance concepts are introduced, because for pure DC, inductor is short, capacitor is open. Then chapter 4 is about AC fundamentals, phasor, J operator, RMS, average values. Chapter 5 is network solution method for sinusoidal, power and power factor. Chapter 6 is the theorems. After learning DC, AC separate, then I am going to mixed theorems, both DC and AC. Then series parallel resonance, magnetic circuits. Then this is transient, which is the last line of the syllabus he mentioned. And then 3-phase circuits. Of course, polyphase circuits is 3-phase. So the same syllabus what he gave, more detailed, I classified into 10, and every chapter, all the details I gave. So if you listen to that 45 hours of recorded classes, network is a cakewalk for you. And please do, of course, practice lot of bits, problems, then you will be very comfortable. It is a cakewalk. Then marks, now that is what you should understand, sir. Electric circuits alone, now see, this is a detailed marks with lot of hard work, after observing so many papers, detail, understanding which subject, which paper. So this is how you please understand. In 2021 mark, yes, 26 is networks, okay, and here 30, 18, 25, you see this is a detailed way. So see the ranges are, how many marks come from my subject alone. It is dominating, sometimes more than machine, sometimes more than power system. Of course, they are core subjects, always bigger, but see these marks, okay. So network theory or circuits is fundamental, and see these marks. So range is, yes, range is 18 to 36 marks, and average is 30 marks. So the range comes from 18 to 36 and average is 30, okay. Then, yes, briefly let us talk about our platform. See, after this COVID, we went into online services. Otherwise, ACE is known for offline generally, but we started online. and excellent services we are providing with high quality content and teachers. So the content is too good. I am telling you that after so many years experience in teaching, teaching in offline platform will give us more flexibility and more matured way of exploring things with a lot of visualization, simulations, etc. And students are definitely liking it. Yes, ACE Online, ACE Academy is 1995, now it is ACE Online, we have integrated it. And this course, please subscribe and ask your friends to go with it. Even this short time you can do wonders just by listening to these compact, precise, accurate videos. Okay, so in that, okay, depending upon the module you select, whether SSC JE, electrical or civil or mechanical, lot of discount is available depending upon the number of days you subscribe, etc. Now sir, okay, so we understood what is SSC JE, number of postings, salary, okay, the type of post available. Then we came to syllabus of my subject, that is electric circuits, detailed syllabus, classification, and marks weightage was very important. Yes, that was very important to talk about this marks weightage. This is very important thing. After going through everything, I concluded it. And then what to study? No doubt, sir, as a teacher, we always inspire you, we always encourage you to go with great materials and textbooks. But in short time, what to do? No doubt these are great books. As a teacher, I follow at any level, whether it is a diploma level or engineering level. For this subject, these are Bible I say, Quran, I say Bhagavad Gita for me. Hayton, Kemerly, Alexander are world's best books, okay? And network analysis and synthesis, Ghosh and Chakrabarti. But studying as a student at this level is unnecessary, okay? As a student, no need. As a teacher, I ask you if you can go, excellent. But in this short time, no need, sir. What to study then? If you can study this, you will become an expert. You will become a number one, as equal to teacher. But in this short time, no need. But still, these are my books I prefer, I refer, okay, as a teacher. Okay, and in ACE, we also provide these books as an additional support. Please subscribe to that material. If you want, buy that material. Visit our ACE publication website. You can get it and we will post you after you pay the DD or you transfer the money. And then, this is the most important material. So, though you cannot read these textbooks, listen to our videos, carefully go through every point there, write short notes, okay? Do that and directly come to this, okay? Of course, now 2024, 23 books are also have come. I am just showing the cover page. These are the books I want you to buy them, okay? Most of you already purchased in the subscription itself, but still, this is the correct material, sir. And you know how much hard work it takes to build such material. See, as a faculty working here, in my time in 2002, 2003 when I passed my BTech, there was no such guidelines, there was no paper available. But today with great difficulty, with RTI Act, getting all those papers and writing solutions so accurately as a team of lecturers here, this is providing you the correct guideline. I never say in such competitive exams, they repeat like your BTech. Don't by heart and don't expect they will repeat. But the correct modulation, correct magnitude and direction of preparation can be easily observed by this material. So this is the material I am suggesting you to buy and read in this short time. And our online videos already have this in detail. So all these bits also has been explained there. So the people who subscribed, yes, this is the correct bandwidth, correct relevant content. I use the term relevancy, relevant. So cracking such exams, what to read, how to read, which way to read, that strategy only will help you, sir. Not that you read everything in the world, okay? So in this short time also, you can absolutely crack, go through this and quick revision. And also additional material relevant to this exam. Relevant to this exam, ESC bits and civil services bits. Yes, civil services, Genco, Transco and ESC bits. Because these bits are without calculator, simple fundamental at SSC JE level. GATE I don't prefer, GATE is next level, okay, ISRO, BARC are next level exams. But at fundamental level, ESC bits, Genco, Transco bits, okay, this also book, all these books are available in ACE, sir. So please do subscribe and buy them, okay, in this short time reading them quickly and solutions are available. If you don't know, you can see and learn and again revise, and that is the way you can attack. All formulas you can go through, that is the way you can attack. Short time, accurate, fast and simple. And this material will help a lot. That is what coaching centers are meant for. Coaching centers are not about teaching everything in the world. We make it simple for you. We are like catalyst in a chemical reaction. I always use this term, okay? What is the role of catalyst? We speed up the reaction. We simplify things for you, okay? So that is the main role of ACE Online and ACE Engineering Academy here. Then what extra as a teacher I can give you? So I gave my recorded lectures, you subscribed, and I told what material to read, okay? And what else we will be giving is, yes, personal notes handwritten. All SSC JE students, you can WhatsApp me, or you can through Fresh Chat app, put a message. I will send you this. And test series, that is what I told, clearing doubts, and Fresh Chat app is integrated to online. So direct contact with teacher you can have, not that we just give recorded videos and we are forgetting you. Throughout the subscription, anytime, any doubt you want to talk, anything you want to raise, please through Fresh Chat, yes, please raise a query, we will immediately respond, okay? Then, yes, now this is what is the highlight I am talking about. Yes, this is what I want to highlight, okay? Yes, preparation strategy, that is the main target for today's session is preparation strategy. Now, these are competitive exams. These are not exams which you wrote in diploma like semester exams or engineering semester exams. These are competitive exams. So understand the difference between university and competitive exams. University exams is about qualifying you. Okay, university exams is about qualifying. You get 60%, 70% distinction, first class, second class. Okay, it is about to learn first. But competitive exam is not just about getting 60, 70%. You have to beat 99% of the competition. Suppose imagine only one post is there out of 100 students, it is beating 99 students. So understand that the difference between university exam and competitive. Most of you are well versatile or well adapted to this university exam. That everyone is doing these days. Okay? But competitive exams is a different level. You have to be very aggressive. Okay? Very accurate, very speed, very simple, fast, calculative. And that comes with lot of practice and experience. Let me tell you. University exams, you have choice, you read 5 out of 8 units, elaborated, simple way, and the teacher evaluates. Even you write 50% of the question, they may give 50% marks. But here it is not the meaning. If you beat, you have to beat the entire competition. So you have to be perfect, speed, accurate and fast. And that all comes with tremendous practice. Practice, revise, practice. That is the major difference between university and competitive exam. Like university exam purpose is to qualify the students. University exam is to qualify. Teacher gives you minimum marks and qualify you, first class distinction. But competitive exams is to eliminate or filter students. So it is a psychology you understand, sir. We are trying to filter you out. Okay? That is the first major difference. It is not about getting that 30% or 60%. It is about beating the competition. So you have to prepare everything. And there is nothing like important or unimportant. Everything you have to prepare, balance all subjects, and in each subject balance all topics. Not that you leave in choice. Not possible. Okay? That is the first thing you have to know. Then in that regard, yes, understand the complete pattern in the syllabus. That is what I was talking. The CBT exam, what it is, then descriptive exam, what it is. So understand the pattern. And syllabus, that is what I was focusing more, syllabus. Then plan yourself based on your strength and important subjects. Okay, actually everything is important, but which is first, which is second, which links what, that you plan it by referring to the previous question. So this is the guidelines. So by referring, yes, which I will talk in my subject also. But based on, yes, your strength and important subject, by taking previous papers, have a plan. Then try to answer lot of previous question papers. That is what I told, sir, that book. Yes, try to answer lot of previous question papers within the given time and you will know where you stand. Then make strategic preparation plan with necessary corrections based on the feedback by writing lot of. So that is why that mock exam also I was highlighting, remember? Write exams. Then you will know whether you are going in right direction, where to improve, what mistakes you are doing. Just like that, without practice and without testing, don't go to the final exam and that day it could be a disaster. So yes, so strategy involves these 5 important steps. Okay, first of all, it is about beating the competition. Okay, understand the pattern in syllabus, understand the strengths of each subject, go in a step. Everything you read, but go in a plan. Okay, where to start, which way to go, and then answer lot of previous question papers and feedback by writing lot of exams for practice. Then what qualities you should have? Yes, dedication and commitment, patience to read and write, adaptability, accountability, and of course intelligence and smart work. So these are the qualities, sir. On the day of exam you have to execute them. Okay, so all this will really matter more. Then let us talk. So after understanding the strategy, the syllabus, okay, which is the main focus, now let us talk about my subject. So as I told, this session will be mostly focusing on okay, on preparation strategy. And I told the marks division, everything. So you can go and repeatedly watch the video where I give the marks, etc. You can pause it and watch. But now let us talk about my subject specifically. So we are all talking about electric circuits or network analysis. Okay. Now, what is so importance of electrical energy? Yes, electrical energy is one of the most dominating and superior forms. As electrical engineers, we are very proud. It is one of the most dominating and superior forms of energy because of many reasons. But the main reason is interconvertibility and also transportation. What is interconvertibility? Interconvertibility is a process of converting different forms of energies into electrical and reconverting them back. That is what interconvertibility means. Like, can you convert heat to electrical? Yes. Geothermal, okay, thermoelectricity, okay, and steam turbines. Can you convert mechanical to electrical? That is what prime movers will do. Can you convert solar to electrical? Yes. Wind to electrical? Yes. Chemical to electrical? Batteries. And the beauty is you can reconvert back. Electrical to heat, electrical to light, electrical to wind, all our ACs, air purifiers, okay, electrical to chemical, electrometallurgical processes. So that is the beauty. That means this energy is highly interconvertible. What is the meaning of interconvertible? We can convert different forms of energy into one common platform. Then we can transport and distribute, and we can convert them back. Okay, and we can convert them. So this process of converting different forms of energy into one common platform and again converting back is called as interconvertibility. Then transportation. Now the beauty is the only energy in the world where we can generate and transport. Yes, the only energy in the world where we can generate and transport in bulk quantities and longer distances, and that too in the most economical way. Yes, most economical way. A most economical way is electrical with minimum losses, high efficiency. Suppose you want to transport energy from one place to another place. Can you take a hot cup of tea and travel to Mumbai and drink from Hyderabad? By the time you reach Mumbai, it will go. But electrical can be transported anywhere in large quantities with highest efficiency. Only requirement is our medium of transmission. Medium of transmissions are our conductors. So yes, this is beauty. One is interconvertibility, different forms, heat, solar, wind, chemical, okay, mechanical. Again, common platform, you can again convert heat, mechanical, chemical, electrical. So that is interconvertibility and transportation. Because of these two unique reasons, this energy is one of the most dominating and superior forms of energies in this modern world. That is why everywhere you see electrification. Today electric vehicles coming, okay, in your out, induction heaters have come, okay, everywhere sir, you imagine there is an automatic, everything has become electric. Automation starts with electrical, okay. So this is superior. And we learn this energy both at signal level and power level. So yes, we learn this energy both at signal level, power level. At power level, it is high level. We talk high voltage, high current, high power, but frequency is 50. So that is power engineering. Power level is power engineering. We also learn this energy at signal level, like low voltage, low current, okay, low power, but high frequencies. Like power system versus communication system. Power system versus communication system. So we learn this energy both at power level and signal level. Okay, power level we call electrical, EC, signal level. But same energy we are talking. So power level is high voltage, high current, high power, but 50 hertz, that is what. And signal level is low voltage, low current, low power, but high frequencies like communication, audio signal, audio processing, video processing, etc. So we learn both, sir. We learn both. Then, yes, this is what I want to highlight. Importance of mathematics in understanding electrical science. So, yes, it is a challenge compared to other departments learning electrical science. What is the challenge? We can learn this energy by using notations and maths. Now, for example, I want to talk about a capacitor. Capacitor is a passive element, okay, which stores and releases energy in electrostatic form. And this capacitor can do so many functions, okay. It can create phase shift, it can create reactive power compensation, it can generate lot of waveforms in integrated circuits. So this is a beautiful component. So capacitor represents electrostatic property of matter, okay, and it can be constructed with dielectric material between two electrodes. But to understand about this, mathematical way we learn. So that involves notations and maths. So Importance of mathematics and laws. That is what I want to highlight. So we can learn electrical engineering, okay, by respecting notations. I say first notations, and second is mathematics, max. What are notations? Notations involve everything. They involve how to represent, taking polarity for voltage, direction for current, units, okay, all these come under notation. Like capacitor, parallel plate capacitor, okay, and it is a passive element. In a passive element, the direction in which current enter is taken as positive. That is the notation. Then how to learn capacitor? Mathematically we learn. Like, yes, the Ohm's law for capacitor is, that is how it learns. Ohm's law for capacitor is, yes, it is I equal to C dV by dt. So to understand capacitor, I learn with Ohm's law, where I is C dV by dt. Now with the help of Ohm's law, I teach capacitor. That is what I am trying to highlight. This energy is easy to learn provided you respect notations and max. Imaginating theoretically, there is no way to learn electrical, sir. We have to learn mathematically. Like example, this is the Ohm's law for capacitor, and in capacitor, yes, I is C dV by dt. Suppose you give pure DC. Suppose if you give pure DC, in a pure DC, dV by dt is 0, current is also 0, capacitor acts as open circuit. If you give pure DC to capacitor, yes, I is also 0, as dV by dt is 0, capacitor acts as open circuit for low frequencies, that is DC signal. Similarly, if I give sinusoidal AC like V equal to Vm sin omega t, if you give V equal to Vm sin omega t, you will get something like I equal to Im sin omega t plus 90. It undergoes phase shift. So in a AC excitation, yes, capacitor, if you give sinusoidal voltage, current is also sinusoidal, but current will lead voltage and it exhibits reactance. That is how mathematically. All this I told in my videos, we will derive, but because I want to inspire you in these few minutes about how to approach and what it involves in my subject. So the way to learn electrical engineering is mathematically. Don't by heart and don't try to learn theory, sir, and don't imagine much. There is beautiful max and all Kirchhoff's law, Ohm's law, so many rules are there, dot convention, mesh and nodal notations. That is the way we learn electrical engineering. So electrical engineering can be learned by using notations and max, example capacitor. So notation involves everything, representation, symbol, polarities, directions, units, mathematics, Ohm's law. So with Ohm's law I will teach everything. Transient chapter I will teach, AC steady state chapter I will teach, DC steady state I will teach, low frequency I will teach, high frequency, everything comes with this simple equation like Ohm's law. For DC, capacitor acts as open circuit, and for AC, capacitor is a reactance leading element. Then sir, this is what I want to highlight. Now my subject, electrical networks or electrical engineering, okay, is primarily divided into these 4 areas, okay. One is DC steady state analysis, okay, ideal DC we imagine, because that is the number 1 waveform at signal level. This is DC steady state analysis, this is the number 1 waveform at signal level. Then basics of time variance. So in this chapter, what I will try to do, I will give time varying signals. If I give pure DC, inductor is short, capacitor is open. Only resistor will work. That is why DC circuit ideally is like only resistive networks. Then when L and C will work, when time variance is given, like triangular waveform, sawtooth waveform, square waveform, then they will work. So this is the part 2, which is basics of time variance L and C. After understanding this RLC components, then I will go to AC steady state, that is sinusoidal steady state analysis. Because number 1 AC waveform is which waveform? Sinusoid. There is a reason for it, and that is the third part. And these are all steady states. DC and AC steady states means settled states. But after understanding steady states, we learn transients. Turning on, turning off, rate of change of voltage, first order circuit, second order circuit. So primarily, my subject has 4 parts, okay? DC steady state, basics of time variance, AC steady state, and also transients, okay? Now, ideal DC steady state. Now, what is ideal DC steady state? Yes, if you observe ideal DC, we give ideal DC voltage waveform. They don't exist, but a new battery or a precision voltage regulator in electronics can give almost ideal DC. And when I give this ideal DC, yes, we know resistor is still homogeneous proportional component, but inductor in steady state acts like short circuit, capacitor in steady state open circuit. So it is like only resistive networks because inductor is short, capacitor open. So when I give ideal DC, this is what happens. Ideally, inductor short, capacitor open, only resistive networks will come. That is why it is like resistive network analysis in the first stage. Then This part will be basics of time variance. Now in this chapter what I will try to do in this part, I will give time varying signal. Like I may give some triangular wave. I can give some square wave. Okay, square wave. Because all electrical engineering is about waveform analysis, generation. Okay, transporting this energy through waveforms. So signal processing. So I may give such time varying waveforms. In the first part I give pure DC. There inductor short capacitor. But when I give such signals, which is basics of time variance, yes, all will respond. Again, resistor is a homogeneous proportional component. Homogeneous proportional. Triangular voltage will give triangular current. Square voltage will give square current. But inductor and capacitor will respond based on Ohm's law. In inductor, yes, V is LdI by dt and I is 1 by L integral V dt. So with this mathematics I will teach. Similarly, in capacitor, I is C dV by dt and V is 1 by C integral I dt. That is how I teach both inductors, capacitors, which is basics of time variance. Okay? Then after understanding these basics of time variance where all will respond, then comes to AC step. That means number one AC waveform. Number one AC waveform is sinusoidal. Sinusoid. Sinusoid means it can be either sine wave or cosine wave. This is going to be the third part where the number one AC waveform is sinusoid. And our power system frequency is how much? 50 Hertz. Okay, our power system frequency is 50 Hertz. Why it is number one? Lot of discussion I did in my class and in my recorded video. But this is the number one waveform at power level. This is the number one waveform at signal level. So DC, signal level, number one waveform. So all our wireless application, portable apparatus, electronic apparatus like DC. But at power level, this is the number one waveform. All induction motors, big pump motors, they want AC. So signal level number one waveform is DC. Power level number one waveform is AC sinusoid. So our entire generation, transmission, distribution and utilization is AC. There are reasons which we will discuss and I discussed in my videos. Go through them. But for this waveform, what happens? If I give these waveforms, resistor is an in-phase element. Resistor is an in-phase. And inductor is a lagging element exhibiting reactance. Lagging means current lags voltage by 90. And a capacitor is a leading element exhibiting reactance where current leads voltage by 90. All will work, but differently they work. Okay, that is about. Then here resonance, magnetic circuits, AC network theorems, power factor calculations, all will come. Then after understanding this DC steady state number one waveform at signal level and AC steady state number one waveform at power level, then the transients will come. Transients. What are transients? Sudden changes. So there is a network, yes, which consists of our components RLC, and I am subjecting this to sudden changes. Sudden changes. Okay, like turning off, turning on, both are transient. Turning on means energy given. Turning off, energy removed. Now in this transient, again these elements behave very differently. Where again resistor is a homogeneous proportional, but at sudden transient T equal to 0 or 0 plus, inductor is open circuit, capacitor is short circuit. Ulta. All we can learn mathematically, sir. In DC what happened? Inductor is short, capacitor is open. But in sudden change, inductor will not allow sudden change. It acts as open. Capacitor will never allow sudden change in voltage short. Ulta. And in this chapter, we need to know what is the order of circuit, what is circuit time constant. Okay? Yes, order, time constant. That is what we have to know. Okay? That is what we have to know and then proceed with the solutions. And here we may use differential equations and Laplace transform. So that is how, yes, transients is the last part. Then there are some miscellaneous topics which I did discuss. The major parts are over, but two ports, network topology, dual duality, locus diagram, network functions, three phase also I discussed, and some of the rare bits came, and in case we can do them. Okay, but the major part is this four. Okay, DC, basics of time variance, AC, and transients. That is how I classify my subject. Okay, then yes, these are miscellaneous topics. Like I will ask you a question. So initially what we do, because we are going to talk about subject now more. Now we classify elements. So that is how we start. Then our basic elements in our networks are classified as either linear, non-linear, passive, active, unilateral, bilateral, lumped, or distributed. So I will give a question stating that, see, the static VI characteristics. What is the meaning static VI means? The steady state VI characteristics of a particular component are shown as below. Okay, this is the characteristics I am giving. Okay, everybody, yes, this is the characteristic I am writing. The steady state VI characteristics of a particular component are shown below. Then what is the nature of the component? Okay, yes, this is the bit given, sir. The steady state VI characteristics of a particular component are shown as below. Then the nature of the component. First of all, is it linear? No, because until here voltage is increasing, current is increasing, but later at this point, though voltage is increasing, current is constant. So saturation is a non-linear. Saturation is a non. Here also, this side voltage is going, this decreasing, current is also decreasing, linear. But after this, even though the voltage is decreasing, current is constant. So because of this saturation, overall element is linear or non-linear? Non-linear, non-linear. Passive or active? First and third quadrant, it is passive. Passive. This all we discussed, okay? First and third quadrant. Unilateral, bilateral, because they are mirror images. Because they are mirror images, it is bilateral. So this was the bit given. What is the nature of the component whose Ohm's law characteristics, not Ohm's law, whose VI characteristics. Ohm's law characteristics means linear. What is the nature of the component if the VI characteristics act like this? So first of all, it is non-linear because saturation. Yes, passive because 1 and 3 quadrant, and bilateral because they are mirror image. So the element is non-linear, passive, bilateral. Okay, then like that we classify and learn. That is a brief way I told. Then these are some important examples which give more clarity for us. Okay, yes, that is about a transistor BJT is globally passive, but locally as an amplifier is active. BJT is a passive element, but as an amplifier we call active. Then most of the semiconductor devices when biased, okay, most of the semiconductor devices when biased, they develop internal cut-in voltages and leakage currents are said to be active. Then inductors, capacitors are passive, please. But when they release energy due to stored energy, that time they are called active. Okay, and op-amp is globally non-linear, but below saturation is linear. So in interview they ask, what is op-amp, linear or non-linear? Actually it is a non-linear. Actually it is a non-linear IC, absolutely. But below saturation it is a linear IC. Then this is one area where a lot of bits came. In SSC JE, this is one area where lot of bits came. Okay, like topological definitions. What is topological definition? These definitions talk about the number of components, their interconnection, etc. Their arrangement. In that, yes, node. Node is a point of interconnection or junction between two or more components. Okay, just briefly, sir. See, this few hours only to inspire you to make your preparation quick. Okay, in that node is a point of interconnection or junction between two or more components. Then branch is an elemental connection between nodes. Degree of a node. How many branches connected at a node represents its degree. If degree is 2, it is called simple node. If degree greater than 2, it is called principal node NP, and that is called junction. So how many branches connected at a node represents its degree. If delta 2, it is called simple node. That means between two elements only, this is called simple node. But if third element is there, it is called principal node, and that is called junction. So any node with more than 2 branches connected is called junction, okay, or principal node. And mesh, what is mesh? Mesh is a closed path which should not have further closed paths, and loops are all possible closed paths. So this will give the way to understand our electrical networks, whether it is a machine network, power system network, measurement network. This is the way we learn how it is arranged and what components are there. Then, yes, after understanding those topological definitions, these are some things you have to remember, that in any circuit or network, number of meshes equal to branches minus nodes plus 1. That means you take any network, number of meshes are branches minus nodes plus 1. The minimum number of KVL equations to solve any circuit is also equal to M. Meshes are specifically called as independent loops. All meshes are by default loops, but all loops are not meshes. And in nodal analysis, mesh analysis KVL equations, how many? This is the direct SSC JE bit. In mesh analysis, how many KVL equations? Meshes only. But in nodal analysis, we neglect simple nodes, but one of the principal node is taken as reference. So minimum equations are principal nodes minus 1. And the last bit, junction is a node with degree greater than 2. Junction is a node with degree greater than 2. So these are the bits which came directly. So this is an area I want to revise, because based on this definition, yes, these bits came. Then, yes, I want to highlight this bit which came 3 times in SSC JE. See this, 3 times it give. See this question, he said, a network has n principal nodes. What is the meaning of principal nodes? With degree greater than 2 and b branches. A network has n principal nodes and b branches. If mesh analysis is simpler than nodal, then n is greater than dash. Now when can you say mesh is simpler than nodal? Simpler means faster, easy. So mesh analysis is simpler than nodal when, yes, when it is simple and faster. So yes, I can say mesh analysis simpler than nodal means number of mesh equations should be less than nodal equations. But what are number of mesh equations? We already know na? Yes, number of mesh equations are b minus n plus 1. That means branches minus nodes plus 1 should be less than nodal. But he said all are principal nodes. All are principal node, there is no simple node. That means all nodes are degree greater than 2. But you know in nodal, one of the principal node is taken as reference node, ground. So how many nodal equations? Principal nodes minus 1. So this is principal nodes minus 1. So mesh analysis is simpler than nodal if the number of mesh equations are less than nodal. So b minus n plus 1 is less than 2n. So if you shuffle them, this is b plus 2 is less than 2n, or I can say b by 2 plus 1 is less than n. So n is greater than b by 2 plus 1. So n is greater than b by 2 plus 1. So when the number of nodes in any network is greater than branches by 2 plus 1, then mesh is faster. Otherwise generally nodal is faster. Okay, that is a bit I want to cover. Then Ohm's law, yes. Then as we go deeper and deeper, classifying elements and their understanding the topology, Ohm's law. Now Ohm's law is a big definition. Okay, Ohm gave his law in linear time invariant domain, in electromagnetic domain, and also electrostatic. Just writing V equal to IR is one of the Ohm's law forms. So at diploma level and this SSC JE level, don't just say V equal to IR. It is one of the form. So there are total 9 forms. Okay. In that, yes, in LTI domain, first of all, J is sigma is the original form, which is in distributed parameters, EMF. We modify this and from that we call V equal to R into I. This is a second form in LTI domain. Okay. And in phasor notation for AC, V is I into R. This is also there. Okay. So this is first, second, and this is seventh form. Okay, out of total 9. Then in electromagnetic domain, inductor will come. Okay. And psi is Li. This is in EMF distributed parameters. We modify this. V is LdI by dt. This is what circuit. Okay. And V is plus JXL into I. This is also there for frequency input. Okay. That is how we all are coming from these basics. Okay. But in and Ohm's law in electrostatic domain. In electrostatic domain, yes, Q is CV is the fundamental Ohm's law in distributed parameters. From that I will get I is C dV by dt. Okay, this is what circuit. And we get V is minus JXC into I for AC steady state for frequency input. So Ohm's law is not just V equal to IR. V equal to IR is one of the form. All these 3 in LTI domain. LTI means linear time invariant. And all these 3 in electromagnetic domain. And all these 3 in electrostatic domain. So all combines Ohm's law, and with this Ohm's law, everything we can learn. For sinusoidal input, square input, triangular input, DC, AC, low frequency, high frequency. That is how we learn mathematically, and Ohm's law is the very important requirement. Then properties of DC supply system. Yes, you know, DC supply systems are unipolar, unidirectional. Okay, there is no change in phase, and this is the number 1 waveform at signal level. Okay, and ideal DC look like this. Okay, ideal DC, yes, ideal DC look like this. Okay, there is no ideal DC everywhere, but a new battery is like ideal DC. Okay, but what rectifiers and DC-DC converters give? Yes, these are practical DC. See, practical DC, you know, this is rectifier, and DC-DC converter like buck converters. These are practical. Ideal DC ripple factor is 0. Practical DC will have ripple factor. Okay, then yes, they are used in small, independent, isolated systems where electrical energy can be stored in small capacities like batteries. And what are the advantages of DC? Yes, superior with respect to precision, accuracy, portability, compact, speed and easy control. DC systems are advantage with that. Okay, then example DC, yes, all our wireless applications, okay, transistor circuits, motherboard components, watches, cell phones, toys, their DC is number 1. Okay, where portability, medical instrumentation, here DC is number 1. So whichever runs with battery, DC. Okay, but they are not powerful, they are small, independent, isolated systems. Okay, then yes, AC. What are properties of AC supply? They are bipolar, bidirectional. There is a phase change and power frequency exists. In India, what is power frequency of AC? 50 Hz. Okay, in that, yes, they are using large, bulk, continuously driven power supply systems where electrical energy cannot be stored. And AC supply driven systems are superior with respect to large power ratings, robust design, rugged construction, less maintenance, high efficiency and large duty cycle. That is very, very important. Okay, and then ideal AC waveform is sinusoid. Ideal AC waveform is sinusoids because its total harmonic distortion is 0. Total harmonic distortion is 0. Example AC, everything. Our entire generation, transmission, distribution, utilization at power level is AC. But practical AC waveform has harmonics like square. This is AC but not ideal AC. Ideal AC is this only because its total harmonic distortion is 0. But here this will have harmonics. Total harmonic distortion exists. That is the meaning. Then we talk about our 5 fundamental components, okay, like voltage source, okay. We know this voltage source definition, okay. Example, what are voltage source? Cell, battery, fuel cell, okay. Photovoltaic solar panels, rectifiers. Then current is rate of flow of charge, we know this, okay. But current sources also are very rare important. Like a BJT in a current mirror is like a current source. Feeder line in power system is like a current source. So don't say current sources are not there. That applications or that sources which can maintain constant current are current sources. So a current mirror circuit in electronics, a feeder line in power system are current sources. Okay. Then resistance, you know resistance, it is a linear time invariant property of matter. And basic construction formula, here we know R is rho L by A. So briefly I am going with sir. So which way? So revision, it's like revision for you. R is rho L by A. Okay, depends upon the resistivity, length of the material and cross-sectional area. Then resistance depends upon temperature. This is very important. RT is R0 into 1 plus alpha T. Okay, if alpha is given at 0. Or I can write R2 is R1 into 1 plus alpha T2 minus T1. This is also correct if alpha is given at T1. If alpha is given at 0 degrees and asking at temperature at T, then this formula. But if alpha is given at T1 and asking resistance and temperature T2, this is the formula. Both mean same, but resistance depends upon temperature. And for semiconductor material, they have negative temperature coefficient. Here alpha is called negative temperature and positive temperature. This is called temperature coefficient of resistance. In semiconductor, it is negative. Negative means, yes, as temperature increases, resistance decreases. But in conductors, it is positive. Okay. Then applications of resistive loads, yes, heater, incandescent bulb, iron box, PCB components, they are all resistors. Then this is how resistor is constructed, and we have this color codes and tolerances. This all I explained because 2-3 SSC JE bits came. Color code, BB Roy, Great Britain versus Great Five, like that we talked now. Yes, okay. Then yes, wattage rating, okay. Electronic level half watt, quarter watt, okay. And this is the meaning. And in even power transmission lines, they also have resistances, okay, like number of strands. Then yes, color code, this concept I told 3-4 bits came, sir. So you have to remember these slides, okay. How to write color code, based on that he asked these questions and that I solved, okay. And tolerances, these are our tolerances, last 3, white, gold, silver are tolerances. So based on that I told here, okay. Okay, like how we got that 4-band and 5-band, higher the band, more accurate precision will improve, but this is 4-band resistor. Like this red, it is 2, okay. Then you see it is violet here, violet, of course colors for you, and then it is brown, okay, brown, 10 to the power of 1. And last is gold, tolerance is plus and minus 5. So based on that we get it. Then, okay, then let us talk about inductor. Inductor is what? Electromagnetic property of matter. Yes, and construction formula, L is nu n square A by L, okay, where permeability of the core, square of the number of turns, cross-sectional area and length of the flux path. Toroid, here also same meaning, but here what is length? Here length of the flux path is the mean circumference length. Same formula, but difference is here also permeability is nu of the core, n is the number of turns of the coil, and A is the cross-sectional area of the coil. But here what is length? Here what is length? 2 pi r. Here length is 2 pi r. Mean circumference length. If this is the radius, 2 pi r circumference. But here length is the length of this material. Okay, that is the difference. Then again, inductance of all such things, a simple wire, hollow cylinder, parallel wires, coaxial, all these I explained, sir. These bits can come. Then applications, yes. What are inductive loads? Yes, heater coil actually. But you talk choke coil is a big inductor. Yes or no? AC machine winding, transformer. These are all inductors. Okay. Then capacitance. It's what? Electrostatic property. Here construction formula C is epsilon A by D. Permittivity of the dielectric, common cross sectional area, distance between the plates. And again capacitance for various configurations. Yes. Okay. This came and all this I explained. And capacitor loads, like you see fan has a capacitor which is phase shifting, all electronic circuits, touch screen of cell phone, okay, there is a capacitor, okay, transmission lines have capacitance, etc. Then ideal voltage source, practical voltage source, ideal voltage source internal resistance 0, constant voltage, practical voltage source small resistance in series, voltage will undergo regulation, ideal current source, stiff current, infinite resistance, practical current source, large resistance, current regulation. Independent sources properties are independent to circuit condition and they are represented by circle symbol. Okay, and dependent sources, they do depend upon some external parameters and they are represented as diamond symbol. Okay, and they are standard 4 types. Okay, like voltage dependent voltage source, voltage dependent current source. Okay, and here current dependent voltage dependent current source and current dependent current source. Okay, so they are standard representations. Okay, all these are important because that is how we can model physical systems. Then what is this is a bit given in SSC JE. Tell me what is the fundamental unit of electrical energy and consumption level, everybody? What is the fundamental unit of electrical energy at consumption level? How much? Yes, it is kilowatt hour. Kilowatt hour. That means 1000 watts consumed in 1 hour is called 1 kilowatt hour. That is one unit of energy. We pay some 3 rupees if it is less than 200 or 7 rupees if it is greater than 200, like that. A tariff system depends. But our unit at consumption level is 1 kilowatt hour. 1 kilowatt hour. Okay, I want to put a slide here. Okay. Now, yeah, after understanding that, yes, now ratings or specifications, we have ratings for all the material and components we take, but as long as we operate them within the ratings, they are said to be linear and Ohm's law. Okay. Yes, ratings represent maximum permissible safe values for continuous operation. We have voltage, current, power and frequency and insulation class ratings. Okay. Above rating damage, below rating deterioration. Like even a normal wire will have rating. Okay. Even a normal domestic consumption wire have ratings. Okay. And wire gauge will decide. See the meaning? Like gauge will decide. Okay. Smaller the gauge, more current. Larger the gauge, less current. Okay. Wire gauge we call. Okay. And even signal diode versus power diode. Signal diode works at electronic level, low voltage, low current, low power. Power diode works at power level, high voltage, high current, high power. Okay. And the difference signal level versus power diode and low wattage, high wattage. See, first of all, low wattage or high wattage. Yes, I want to talk low wattage or high wattage, everybody. Yes, in low wattage or high wattage, what I want to talk is, first of all, yes, voltage is same. So whether it is low wattage or high wattage, voltage is same. But low wattage will consume less current, high wattage will consume more current. But what is the design requirement? For low current, conductor cross-sectional area is low. And for high current, conductor cross-sectional area is high. Okay. Then in that regard, yes, I told the example there, like if you take Suppose an example, a 220 volt DC motor with armature resistance of 1 ohm and a 220 volt DC motor with armature resistance of 0.2 ohm. So which is high horsepower? See here, voltage is same first of all both motors, but here armature resistance more. Armature resistance more means thinner wire, because less cross sectional area, more resistance. Thinner wire means less current. Less current, same voltage is less power. So it is low horsepower. Here, yes, here armature resistance is less. So thicker wire, high resistance. So high horsepower. Okay. So high resistance is thinner wire, low horsepower, less current. Less resistance means thicker wire, more current, high horsepower. So based on that we can say. Okay. So this question papers, yes, we will continue in session 2. That is what I want to say. Okay. Today I gave the strategy, introduction, the way we go, what to study, how to study, etc. But question papers, pattern of questions will be continued in second session. That is on, yes, 12th May, 7 to 8. Don't miss it. Okay. That is day after tomorrow, exactly 48 hours from now. And yes, thank you. Okay, we will continue part 2 to discuss more accurate and unique questions of SSC JE. Don't miss that session. Okay, meanwhile, ramp up your preparation. Don't give up. Continuous hard work, and we will meet you on Sunday.